Today we'll discuss one of the most iconic and feared machine guns. The distinctive sound was unmistakable, a high-pitched, ripping buzz that could tear through the air at over 1,200 rounds per minute. Allied soldiers who heard it never forgot it. They called it Hitler's Buzzsaw, Hitler's Zipper, or simply the Bone Saw. The Germans called it the Maschinengewehr 42, or MG42, and it represented one of the most devastating infantry weapons ever deployed on a battlefield. When the MG42 made its combat debut on the Eastern Front in 1942 and subsequently appeared in North Africa and Italy before becoming ubiquitous on the Western Front, it fundamentally changed the nature of infantry combat. This weapon didn't just kill effectively, it terrorized, suppressed, and dominated the battlefield in ways that few other small arms have managed before or since. Its psychological impact was nearly as important as its tactical effectiveness, and both were formidable. This is the story of how German engineering created a machine gun so effective that its basic design continues to influence military small arms development, more than 8 decades after its introduction. It's a story of innovation born from necessity, of manufacturing genius applied to warfare, and of a weapon that would earn a reputation as perhaps the finest general-purpose machine gun ever created. To understand the MG42, we must first understand the crisis that gave birth to it. The story begins not with the MG42 itself, but with its predecessor, the MG34. The MG34, introduced in 1934, was itself a revolutionary weapon. It was the world's first true general-purpose machine gun, GPMG, a concept that would become standard worldwide, but was radical at the time. The MG34 could serve as a light machine gun fired from a bipod, a heavy machine gun mounted on a tripod, an anti-aircraft weapon, or even a vehicle-mounted weapon. This versatility was unprecedented and reflected German military doctrine that emphasized flexibility and adaptability. The MG34 was an engineering masterpiece, precision machined to exceptionally tight tolerances. It was reliable, accurate, and capable of sustained fire rates of up to 900 rounds per minute. It used a recoil-operated mechanism and featured a quick-change barrel system that allowed crews to swap out overheated barrels in seconds, maintaining the weapon's ability to deliver sustained fire. However, the MG34 had critical flaws that would become apparent as Germany plunged into a global war of unprecedented scale. The weapon was expensive to manufacture, requiring extensive machining and skilled labor. Each MG34 took approximately 150 hours to produce, utilizing precision milling and turning operations that demanded specialized equipment and expertise. The weapon required dozens of precision-machined parts, many of which had to be hand-fitted during assembly. Moreover, the MG34's tight tolerances, while contributing to its accuracy and smooth operation, made it vulnerable to jamming in adverse conditions. Mud, sand, extreme cold, and the general filth of combat could cause malfunctions. On the Eastern Front, where German forces faced both the brutal Russian winter and the endless expanses of dusty summer steppes, these vulnerabilities became critical liabilities. By 1941, Germany faced a manufacturing crisis. The invasion of the Soviet Union, Operation Barbarossa, had created enormous demands for weapons and equipment. The Wehrmacht was suffering catastrophic losses in men and materiel on the Eastern Front, while simultaneously fighting in North Africa and maintaining occupation forces across conquered Europe. The Kriegsmarine needed weapons for its expanding U-boat fleet and surface vessels. The Luftwaffe required defensive armament for its bombers and fighters. Germany's industrial capacity, already stretched thin, could not keep pace with demand. The MG34, despite its excellence as a weapon, had become a production bottleneck. German military planners recognized that they needed a machine gun that could match or exceed the MG34's combat effectiveness, while being far simpler and faster to manufacture. The challenge was daunting. Create a weapon that maintained the tactical flexibility and firepower of the MG34, but do so using manufacturing methods that could be executed by less skilled workers using less specialized equipment and in a fraction of the time. The solution came from an unlikely source. Dr. Werner Gruner was a brilliant firearms designer working for Metal und Lackierwaren Fabrik, Johannes Grossfuss AG, a company based in Dobeln that had no previous experience in weapons manufacturing. Before the war, the company had produced metal goods and lacquered items. A far cry from precision firearms, Gruner approached the weapon design challenge with fresh eyes, unburdened by traditional gunsmithing orthodoxy. He recognized that the key to rapid production lay in extensive use of stamping and welding, rather than machining. Metal stamping, pressing sheet metal into desired shapes using dies, was far faster than milling or turning, and could be performed by workers with minimal training. Welding could join components that traditionally required precision machining and fitting. This approach was revolutionary in firearms design. Stamped metal parts had been used in firearms before, but never to the extent that Gruner proposed. Many traditional gunsmiths viewed stamping as cheap and inferior to proper machining. Gruner saw it as the future. Working with a small team, Gruner designed a weapon that would use approximately half the machined parts of the MG34, replacing them with stamped components. The new weapon would require only about 75 hours to produce, half the time needed for the MG34. Perhaps most importantly, it could be manufactured using simpler tooling and less skilled labor, freeing up specialized workers and machinery for other critical war production. The weapon that emerged from Gruner's work was designated the MG39-41 during development, later becoming the MG42 when it entered production in 1942. While it shared the general-purpose concept and quick-change barrel system with the MG34, it was fundamentally different in construction and operation. The most significant innovation was the operating system. Gruner abandoned the MG34's recoil operation in favor of a short recoil system using a roller-locked bolt mechanism. This system, which would later influence numerous firearms designs including the famous Setme and Heckler and Koch G3 rifles, was brilliantly simple yet effective. When the weapon fired, the barrel and bolt assembly recoiled together for a short distance. During this recoil, two rollers in the bolt were forced inward by angled surfaces in the barrel extension, unlocking the bolt. The barrel then stopped moving while the bolt continued rearward, extracting and ejecting the spent cartridge case. A return spring then drove the bolt forward, stripping a fresh round from the belt, chambering it, and forcing the rollers back out into their locked position. The firing pin then struck the primer, and the cycle began again. This system was mechanically elegant and incredibly robust. The roller-locked mechanism could handle the pressures of sustained automatic fire while being relatively insensitive to dirt and fouling. The rate of fire was controlled primarily by the bolt's mass and the spring tension, both easily adjustable parameters. The body of the weapon was constructed primarily from stamped steel pressings that were welded together. The receiver was made from two stamped halves joined by welding. The barrel shroud, receiver cover, and many other components were stamped rather than machined. Only critical parts like the barrel, bolt components, and firing mechanism required precision machining. The result was a weapon that looked cruder than the elegantly machined MG34, but was actually more reliable and far easier to produce. The MG42 didn't have the MG34's refined appearance, but it had something more important. It worked, and it could be manufactured in quantity. #Technical specifications and capabilities. To truly understand why the MG42 was so feared, we need to examine its technical characteristics in detail. The MG42's most distinctive characteristic was its phenomenal rate of fire, typically between 1,200 and 1,500 rounds per minute, depending on the specific variant and manufacturing tolerances. This was 50% faster than the MG34, and nearly double the rate of most other contemporary machine guns. To put this in perspective, the American M1919 Browning machine gun fired at 400 to 600 rounds per minute. The British Bren gun managed 500 to 520 rounds per minute. Even the Soviet SG-43 Goryunov, introduced in 1943 as a response to German machine gun superiority, only achieved 600 to 700 rounds per minute. The MG-42's rate of fire was in a class of its own. This extraordinary rate of fire had several important tactical implications. First, it created devastating suppressive fire. When an MG-42 opened up, the sheer volume of bullets made it nearly impossible for enemy troops to move or return effective fire. The psychological effect was immense. Soldiers described the sound as a continuous roar or rip rather than individual shots, making it difficult to tell where one burst ended and another began. Second, the high rate of fire meant that even short bursts put multiple rounds on target. A 2-second burst from an MG-42 would send 40 to 50 rounds downrange, while a comparable burst from a Browning M1919 would only launch about 20 rounds. This meant the MG-42 could effectively engage targets with shorter bursts, conserving ammunition while maintaining effectiveness. Third, the rate of fire contributed to the weapon's effectiveness against moving targets, particularly aircraft. When used in an anti-aircraft role, the MG-42's high rate of fire increased the probability of scoring hits on fast-moving aerial targets. However, this phenomenal rate of fire also had drawbacks. Ammunition consumption was prodigious. An MG-42 crew could exhaust their ammunition supply in minutes of sustained firing. Barrel heating was extreme, requiring frequent barrel changes during extended engagements. The high rate of fire also created increased recoil forces and muzzle climb, making the weapon less accurate during sustained fire compared to slower-firing weapons. The MG-42 was chambered for the 7.92 by 57mm Mauser cartridge, the standard German rifle round. This was a powerful, effective round with good ballistic properties. The full-powered rifle cartridge gave the MG-42 an effective range of approximately 1,000 meters when fired from a bipod and up to 2,000 meters when mounted on a tripod, though practical effective range was typically shorter. The use of a full-powered rifle cartridge was standard for machine guns of the era, but it meant that the weapon and its ammunition were heavy. This was partially offset by the MG-42's construction methods, which made it lighter than many comparable weapons despite its robust design. The MG-42 weighed approximately 11.5 kilograms, 25.35 pounds, unloaded, slightly lighter than the MG-34's 12.1 kilograms, despite the newer weapon's higher rate of fire and robustness. This relatively light weight for such a powerful weapon was another testament to the efficiency of Gruner's design. When configured with a bipod for the light machine gun role, the weapon could be carried and operated by a two-man team, a gunner and an ammunition bearer assistant. When mounted on the heavier Lafette tripod for sustained fire missions, the complete system weighed approximately 20 kilograms for the tripod and another 11.5 for the gun, plus ammunition. One of the most important features inherited from the MG-34 and refined in the MG-42 was the quick-change barrel system. The high rate of fire generated tremendous heat, causing barrels to glow red-hot during sustained firing. Without a quick-change capability, this would have limited the weapon's sustained fire capability. The MG-42's barrel could be changed in approximately 5 seconds by a trained crew. The barrel change procedure was simple. The gunner or assistant would flip open a latch on the receiver, rotate the receiver cover to the side, grasp the hot barrel with an asbestos mitt or glove, pull it straight out of the receiver, insert a fresh barrel, close the receiver cover, and lock the latch. The weapon was then ready to resume firing. This capability meant that an MG-42 crew with spare barrels could maintain sustained fire almost indefinitely, as long as ammunition held out. Standard practice called for barrel changes after firing 250 rounds in rapid succession, or after extended periods of firing that caused the barrel to overheat. A well-trained crew typically carried 3 or 4 spare barrels. The barrels themselves were manufactured to loose tolerances compared to rifle barrels, accepting that the high rate of fire and rapid barrel changes made extreme accuracy less important than reliability and volume of fire. This further simplified production. The MG-42 used a belt-fed system, feeding from non-disintegrating metallic link belts. These belts were typically organized into 50-round sections that could be linked together for longer belts. The ammunition was typically carried in metal drums or cans that protected the belts, and ammunition from the elements. The feed mechanism was reliable and could handle being pulled from either side of the weapon, making it adaptable to different tactical situations. The ejection port could also be configured for either left or right ejection by swapping a simple cover, adding to the weapon's flexibility. While the MG42 was not a precision weapon in the same sense as a rifle, it was reasonably accurate for a machine gun. When fired from the tripod mount with proper technique, experienced gunners could achieve consistent hits on man-sized targets at ranges exceeding 800 meters. The high rate of fire actually contributed to hit probability through the concept of beaten zone, the elliptical area on the ground where bullets from a sustained burst would land. The MG42's high rate of fire created a dense beaten zone that increased the probability of hitting targets within that area, even if individual bullet placement was less precise than slower-firing weapons. The tripod-mounted configuration, known as the Lafette 42, included sophisticated sighting equipment that allowed for indirect fire missions and precise range estimation. This made the weapon effective for area denial and defensive fire missions at extended ranges. The MG42's design innovations went far beyond its mechanical operation. The true genius of the weapon lay in how it could be manufactured. The extensive use of stamped components was the key to rapid production. Approximately 50% of the MG42's parts were created through stamping operations, compared to less than 10% in the MG34. This represented a paradigm shift in firearms manufacturing. Metal stamping operations are fast and require relatively low skill levels. A single die set can produce hundreds or thousands of identical parts with minimal supervision. Once the dies were created and the stamping presses set up, workers with minimal training could produce parts at rates that precision machining could never match. The receiver, for example, was made from two stamped halves that were then welded together. This construction method was far faster than machining a receiver from solid steel bar stock, and the resulting assembly was actually stronger in many ways, due to the absence of stress concentrations that machining operations can create. The barrel shroud, trigger housing, and numerous other components were similarly stamped. Even components that had complex shapes could be created through progressive stamping operations, where the metal passed through a series of dies that gradually formed it into the final shape. Where the MG34 relied heavily on precision machining and hand-fitting of components, the MG42 used extensive welding. Spot welding and seam welding joined stamped components quickly and reliably. The welds didn't need to be beautiful, they just needed to be strong and gas-tight where necessary. This approach horrified traditional gunsmiths, who viewed welded assemblies as crude and inferior. But Gruner and his team understood that perfection was the enemy of good enough, especially in wartime production. A welded joint that was strong and reliable was entirely adequate for a machine gun, even if it lacked the aesthetic appeal of a precision-machined and hand-fitted assembly. The assembly process itself was simplified through modular design. Major subassemblies could be manufactured and tested separately, then brought together for final assembly. This allowed for parallel production processes and made quality control more manageable. The results spoke for themselves. While the MG34 required approximately 150 man-hours to produce and cost roughly 327 Reichsmarks, the MG42 needed only about 75 man-hours and cost approximately 250 Reichsmarks, a reduction of 50% in both time and cost. Production ramped up rapidly. After initial production began in 1942, German industry produced approximately 17,500 Ming-Gi 42s by the end of that year. In 1943, production surged to over 111,000 milligrams 42s, over 211,000 weapons, despite Germany's increasingly desperate strategic situation, Allied bombing of industrial facilities, and chronic shortages of raw materials and skilled labor. The weapon's design made it possible to maintain production even as conditions deteriorated. The MG42's design also facilitated distributed manufacturing. While the original manufacturer, Grossfuss OG, remained a major producer, numerous other facilities were brought into the production network. Mauserwerk, Daimler-Puch and other firms manufactured MG42s. Component manufacturing was spread across even more facilities. This distributed production model made the manufacturing base more resilient to Allied bombing. The destruction of a single facility wouldn't cripple production, as other facilities could compensate. Additionally, if a facility specialized in producing particular subassemblies or components, its loss could be made good by retooling other facilities relatively quickly due to the weapon's modular design and simple manufacturing processes. The MG42's design also made efficient use of materials. At a time when Germany faced increasing shortages of critical materials, particularly high-quality steel alloys and strategic metals like chromium, the weapon's design minimized waste. Stamping operations produce less scrap than machining. When a part is machined from bar stock, much of the original material is removed as chips and shavings. Stamping, by contrast, forms the part from sheet stock with minimal waste. The scraps from stamping operations could be recycled more easily than machining waste. The modular design also meant that if a component failed quality control, only that specific part needed to be scrapped and remade, not an entire complex assembly that might represent dozens of hours of skilled labor. The MG42 wasn't just a weapon. It was the centerpiece of German infantry tactics. Understanding how it was employed helps explain why it was so effective and so feared. German infantry doctrine in World War II was built around the machine gun squad, or group. Unlike Allied forces, which generally organized squads around riflemen with a machine gun as a support element, German squads were explicitly organized to support and protect the machine gun. A typical German infantry squad consisted of 10 men, a squad leader, Gruppenführer, a machine gunner, Maschinengewehrschütze, an assistant gunner, Hilfsschütze, and 7 riflemen. The machine gun was the squad's primary weapon. The riflemen existed primarily to protect the machine gun crew, to carry ammunition, and to exploit opportunities created by the machine gun's fire. This organization reflected a fundamentally different tactical philosophy from the Allies. German doctrine emphasized the machine gun as the primary source of firepower and maneuver element, with riflemen providing security and support. Allied doctrine generally emphasized riflemen as the primary maneuver element, with machine guns providing supporting fire. The MG42's high rate of fire and reliability made it ideal for fire and maneuver tactics. In an attack, the machine gun would establish a base of fire, suppressing enemy positions with devastating firepower. Under this suppressive fire, rifle teams would maneuver to assault positions or advantageous firing positions. The volume and continuity of fire from an MG42 made it exceptionally effective in the suppressive role. Enemy troops could not raise their heads to observe or fire effectively when an MG42 was hosing down their position. This allowed German infantry to maneuver with reduced casualties. In defense, the MG42's capabilities were even more pronounced. German defensive doctrine called for establishing mutually supporting machine gun positions with overlapping fields of fire. The high rate of fire and excellent range meant that relatively few MG42s could cover large areas with devastating fire. German defensive tactics relied heavily on the concept of creating killing zones, areas of ground that could be covered by concentrated machine gun fire. Defensive positions were selected and prepared to maximize the effectiveness of machine gun fire, with positions sited to provide long fields of fire across likely avenues of approach. When attacking Allied forces entered these killing zones, they would be subjected to fire from multiple MG42s simultaneously. The psychological and physical effects were devastating. Many Allied accounts describe the terror of being caught in such fire, unable to advance or retreat, watching comrades fall while the air filled with the buzzsaw sound of multiple MG42s. The MG42's sustained fire capability was critical to this doctrine. Unlike weapons that would overheat or jam during extended firing, the MG42 with its quick-change barrels could maintain fire as long as ammunition lasted. This meant that defenders could keep a killing zone under continuous fire, preventing enemy forces from crossing. The general-purpose concept meant that the same weapon could fulfill multiple roles with minimal reconfiguration. A squad could use its MG42 as a light machine gun during movement and maneuver, mounted on its bipod and fired from the shoulder or prone position. When establishing a defensive position or support by fire position, the same weapon could be mounted on its tripod for improved accuracy and sustained fire capability. This flexibility was a force multiplier. Instead of needing separate weapons for different missions, German units could rely on the MG-42 to fulfill multiple roles. This simplified logistics, training, and tactical planning. The true measure of any weapon is its performance in combat. By this measure, the MG-42 was exceptional. The MG-42 made its combat debut on the Eastern Front in 1942, arriving at a critical time for German forces. After the catastrophic winter of 1941–42 and the failure to capture Moscow, German forces were preparing for renewed offensives in southern Russia that would culminate in the Battle of Stalingrad. Soviet infantry tactics at this time relied heavily on massed infantry assaults. Soviet commanders, facing enormous pressure to recapture territory and achieve objectives regardless of cost, often threw waves of infantry at German positions. Against such tactics, the MG-42 proved devastatingly effective. German defenders armed with MG-42s could break up Soviet assaults with withering fire. The high rate of fire meant that even relatively small numbers of machine guns could create fire density sufficient to stop or disrupt attacks by numerically superior forces. Soviet after-action reports from this period frequently mentioned the devastating effectiveness of German machine guns, though many Soviet soldiers couldn't distinguish between the MG-34 and the newer MG-42. The weapon's reliability in harsh conditions was also proven on the Eastern Front. The Russian winter tested all equipment to the extreme, and many weapons failed under the stress of extreme cold, snow and ice. The MG-42, despite initial concerns about its stamped construction, proved surprisingly robust. Its looser tolerances actually made it less susceptible to jamming from dirt and debris than the more precisely machined MG-34. In the summer, when the steppes turned to dust, the MG-42 again demonstrated superior reliability. The dust that clogged and jammed more delicate weapons had less effect on the MG-42's robust mechanism. When the MG-42 reached North Africa and later Italy, it faced different environmental challenges and tactical situations. In the desert, sand and dust were constant problems for all weapons. The MG-42's relative immunity to fouling made it valuable in these conditions. During the fighting in Tunisia in 1942–43, German and Italian forces used MG-42s effectively in defensive positions against advancing Allied forces. The weapon's long range and accuracy were particularly valuable in the open terrain of North Africa, where fields of fire could extend to 1,000 meters or more. In Italy, the mountainous terrain created different challenges. The MG-42's portability became important, as machine gun teams had to move through difficult terrain to reach firing positions. The weapon's ability to provide devastating suppressive fire was crucial in the mountain warfare that characterized the Italian campaign, where small unit engagements and defensive positions on hilltops and ridgelines were common. The fighting at Monte Cassino, Anzio, and along the Gothic line all featured extensive use of MG-42s by German defenders. Allied forces attacking up slopes into prepared positions found themselves subjected to murderous machine gun fire. The MG-42's ability to keep attacking forces pinned down while German forces maneuvered or withdrew was demonstrated repeatedly. The Western Front after D-Day represented the sternest test of the MG-42 and the tactical doctrine built around it. Here, German forces faced Allied armies with overwhelming advantages in numbers, artillery, air power, and armor. Yet the MG-42 played a crucial role in the stubborn German defense that characterized the fighting in France, the Low Countries, and Germany itself. At Omaha Beach on D-Day, MG-42s positioned in the bluffs overlooking the beach created some of the most deadly killing zones of the war. American troops wading ashore and crossing the beach were subjected to murderous machine gun fire. The distinctive sound of the MG-42 became seared into the memory of every soldier who survived Omaha Beach. One position, later designated WN-62, housed several MG-42s with clear fields of fire across the beach. The gunner in this position, Heinrich Sevelow, later estimated that he fired approximately 12,000 rounds during the battle. While this number may be inflated, it illustrates the MG-42's capacity for sustained fire and its devastating effect on attacking forces. In the hedgerow country of Normandy, the bocage, the MG42 was equally effective. The dense hedgerows and small fields created countless opportunities for ambush and defense in depth. German forces would position MG42s to cover lanes between hedgerows and openings in the thick vegetation. Advancing Allied troops would suddenly find themselves under fire from concealed positions, often with deadly results. The tactical problem the MG42 posed is evident in Allied training materials and combat reports from the period. American and British forces developed elaborate tactics to suppress and eliminate MG42 positions, including extensive use of artillery, smoke, flanking maneuvers, and combined arms coordination. The fact that such elaborate methods were necessary speaks to the weapon's effectiveness. During the Ardennes offensive, Battle of the Bulge in December 1944, the MG42 played a significant role in the initial German successes. German assault units used MG42s to provide suppressive fire during their attacks, while defensive positions established to hold captured territory relied heavily on the weapon. American forces, caught off guard by the offensive, found themselves subjected to the same devastating machine gun fire that had characterized the fighting since Normandy. The MG42's effectiveness in both offensive and defensive roles was again demonstrated, even as Germany's strategic situation had become hopeless. Beyond its tactical effectiveness, the MG42 had a profound psychological impact on Allied soldiers. This psychological dimension of the weapon's effectiveness deserves separate examination. The MG42's extremely high rate of fire created a sound unlike any other weapon on the battlefield. Where other machine guns produced a distinct rat-tat-tat of individual shots, the MG42's rate of fire was so high that individual shots blurred together into a continuous ripping or tearing sound. Allied soldiers described it variously as sounding like tearing cloth or canvas, a buzzsaw cutting through wood, a zipper being pulled, thunder, or a prolonged roar. This distinctive sound was instantly recognizable and became deeply associated with danger and death. Veterans speak of the visceral fear induced by hearing that sound, even decades after the war. The sound meant that somewhere nearby, an MG42 was sending 1,200 or more rounds per minute downrange, and soldiers in its beaten zone had seconds to find cover or die. The psychological suppressive effect of the MG42 went beyond the actual physical danger it posed. Even when an MG42 wasn't firing directly at a particular position, the sound of it firing nearby could make soldiers reluctant to move or expose themselves. The weapon created a zone of fear, larger than its actual effective killing zone. Training materials from the period attempted to help soldiers overcome this psychological effect. American and British instructors would play recordings of MG42 fire and teach soldiers to recognize the sound without panicking. The fact that such training was deemed necessary illustrates the weapon's psychological impact. Combat accounts are filled with references to the fear induced by the MG42. Stephen Ambrose, in his books on American soldiers in World War II, compiled numerous veteran testimonials describing encounters with the weapon. A common theme is the overwhelming sense of helplessness when caught under MG42 fire, the feeling that the air itself was filled with bullets and that survival was purely a matter of luck. British veterans of the Italian campaign describe similar experiences. One account describes an entire platoon pinned down by a single MG42 for hours, unable to move or effectively return fire. Watching as attempting to maneuver resulted in immediate casualties. The psychological impact was amplified by the weapon's reliability. Other machine guns might jam or overheat, offering temporary respite. The MG42, with its quick-change barrel system, could maintain fire almost indefinitely. This created a sense of relentless, inescapable danger. The fear of the MG42 influenced tactical decisions at all levels. Commanders knew that their troops would take disproportionate casualties when attacking positions defended by MG42s. This influenced planning, with commanders allocating extra resources, artillery, air support, armor, to suppress or eliminate known MG42 positions before committing infantry. At the small unit level, squad and platoon leaders developed elaborate techniques to avoid or suppress MG42 positions. The weapon forced a level of tactical caution that slowed Allied advances and increased casualties. The effectiveness of the MG42 forced Allied armies to develop counter-tactics and to re-evaluate their own small arms programs. Allied forces eagerly captured MG42s whenever possible and used them against their former owners. American, British, and Soviet forces all used captured MG42s extensively, demonstrating the universal recognition of the weapon's excellence. Using captured weapons created logistical complications, as it required stockpiling captured ammunition and spare parts. Despite these challenges, units that captured MG42s often retained them, considering them superior to their issue weapons. The MG42's effectiveness prompted Allied nations to re-evaluate their own small arms programs. The Americans, in particular, recognized that their standard squad automatic weapon, the Browning automatic rifle BAR, was inadequate compared to the MG42's capabilities. Post-war, American efforts to develop a general-purpose machine gun led to the M60, which drew inspiration from the MG42's design, particularly its feed system and quick-change barrel. The M60 became the U.S. military's standard GPMG during the Vietnam War era. The British continued to use the Bren gun through World War II, but eventually replaced it with the L7 general-purpose machine gun, a license-built version of the Belgian FN mag, which itself showed design influence from the MG42. The Soviets, despite developing effective machine guns like the SG-43 Goryunov, continued to study and learn from captured MG42s. Soviet post-war machine gun development showed clear influence from German designs. While the basic MG42 design remained largely unchanged throughout the war, several variants and adaptations were developed. After the war, Yugoslavia acquired MG42 manufacturing equipment and began producing a modified version designated the MG42-59. This version was chambered for the Soviet 7.6 2x39mm M43 cartridge, reflecting Yugoslavia's position between East and West during the Cold War. Later, Yugoslavia also produced the M53, a version chambered for the standard 7.6 2x54 MMR Soviet cartridge. These Yugoslav variants demonstrated the adaptability of the basic MG42 design to different cartridges and confirmed the soundness of Gruner's original engineering. Near the war's end, Germany developed the MG45, also designated MG42V, an improved version that incorporated lessons learned from combat use. The MG45 featured a slightly different operating mechanism and improved manufacturing techniques that would have further reduced production time and costs. However, the MG45 never entered large-scale production before Germany's surrender. A few prototypes and pre-production examples were made, but the weapon's development came too late to affect the war's outcome. The MG42 was adapted for use as aircraft armament and vehicle-mounted defensive weapons. These applications required modifications to the basic design to accommodate different mounting systems and firing controls. As aircraft armament, the MG42, sometimes designated MG81, was used in defensive positions on German bombers and other aircraft. The high rate of fire was valuable in air combat, where engagement times were brief and fast-moving targets required maximum hit probability. On vehicles, the MG42 was used as defensive armament on tanks, armored vehicles, and even submarines, for anti-aircraft defense when surfaced. The weapon's reliability and firepower made it ideal for these applications. The end of World War II did not end the MG42's story. Indeed, in many ways, its influence became even more apparent in the decades following the war. When West Germany rearmed in the 1950s and joined NATO, the new Bundeswehr needed a machine gun. Rather than develop an entirely new weapon, German engineers returned to the MG42 design. The result was the MG1, which was essentially an MG42 rechambered for the NATO standard 7.6 2x51mm cartridge. The MG1 was quickly superseded by the improved MG3, which featured minor modifications but retained the essential MG42 design. The MG3's operating system, quick-change barrel, general-purpose concept, and even its external appearance were nearly identical to its World War II predecessor. The MG3 entered service with the Bundeswehr in 1968 and remains in service today, more than 50 years later. This longevity is remarkable for any military equipment and speaks to the fundamental soundness of the original MG42 design. Numerous countries adopted the MG3 or license-produced variants. Italy, Spain, Pakistan, Turkey, Iran, and many others have used the weapon. Production of the MG3 and variants has exceeded 1 million weapons over the decades since its introduction. Perhaps the most remarkable aspect of the MG42's legacy is that the weapon itself, in its MG3 form, continues to see combat use in the 21st century. German forces used MG3s in Afghanistan. Pakistani forces used them along the Kashmir border. Turkish forces employ them in various conflicts. The design that ended combat in 1942 remains relevant on battlefields more than 80 years later. This longevity is virtually unprecedented for infantry weapons. Few firearms designs remain in frontline military service after 8 decades. That the MG42 MG3 has done so demonstrates not just the quality of the original design, but also its fundamental suitability for the machine gun role. The MG42 served as a significant force multiplier for German forces. Outnumbered and out-resourced, German units could use superior weapons and tactics to partially offset Allied numerical superiority. A German infantry squad built around an MG42 could engage and defeat larger Allied units under favorable circumstances. This meant that Germany could hold defensive positions with fewer troops than would otherwise be required, freeing up forces for use elsewhere or simply allowing stretched forces to cover more ground. The MG42 played a role in the stubborn German resistance that characterized the Allied advance through Western Europe after D-Day. While Germany's strategic defeat was inevitable given Allied superiority in virtually every category of military power, the MG42 helped make that advance costly and time-consuming. Each day that German forces held up the Allied advance was another day for Germany to produce weapons, train troops, and potentially develop wonder weapons that might change the strategic situation. While ultimately futile, the MG42's effectiveness in defensive combat contributed to Germany's ability to resist for nearly a year after D-Day. The MG42 inflicted disproportionate casualties on Allied forces. While precise attribution is impossible, machine gun fire generally accounts for a significant portion of combat casualties, and the MG42's effectiveness likely made that proportion higher when facing German forces. High casualties meant more experienced soldiers lost, more time needed for units to recover and integrate replacements, and potentially reduced morale and combat effectiveness among Allied units. While Allied material superiority allowed them to absorb such losses, the MG42 made the price of victory higher than it would otherwise have been. Was the MG42 truly the most feared weapon on the Western Front? The question is subjective, but strong arguments support the claim. From a purely technical perspective, the MG42 was arguably the finest machine gun of World War II and certainly one of the best infantry weapons ever developed. Its combination of rate of fire, reliability, versatility, and manufacturability was unmatched. The fact that modern militaries still use its direct descendant, the MG3, more than 80 years after its introduction is powerful testament to the design's excellence. Tactically, the MG42 was devastatingly effective. It could break up attacks, suppress enemy forces, cover defensive sectors, and provide assault fire. Its flexibility allowed it to fulfill multiple roles, simplifying logistics and tactical planning. The weapon's reliability meant that commanders could count on it to function when needed, yet for all its technical excellence and tactical effectiveness, the MG42 was ultimately just a tool used by human beings in the service of a horrific ideology and a criminal regime. The weapon itself was neither good nor evil. That moral character came from the cause in which it was employed. Many of the soldiers who faced the MG42 were fighting to defeat fascism and liberate Europe from Nazi tyranny. The weapon made that fight harder and more costly. In that context, its effectiveness is tragic. Each Allied soldier killed or wounded by an MG42 was a person fighting for a just cause against evil. The German soldiers who operated MG-42s ranged from true believers in Nazi ideology to conscripts who had no choice but to fight. Some were war criminals who committed atrocities. Others were ordinary men caught in extraordinary circumstances, fighting desperately for survival as their nation collapsed around them. The weapon itself is fascinating from technical, historical, and military perspectives. It represents a peak of firearms engineering and design. But we should never forget the human cost of war and the reality that this weapon, however excellent from a technical standpoint, was used to kill people, some fighting for tyranny, others fighting against it. The MG-42 earned its fearsome reputation through demonstrated excellence in combat. It was superior to Allied machine guns in most respects and served as the centerpiece of German infantry tactics. Its psychological impact was profound, and its influence on firearms development continues to the present day. For Allied soldiers on the Western Front and on other fronts where it was employed, the MG-42 was indeed one of the most feared weapons they would encounter. The sound of Hitler's buzzsaw meant that death was filling the air at 1,200 rounds per minute, and survival was often a matter of luck more than skill. That fear was well-founded. The MG-42 was a superb weapon in the hands of a well-trained crew, capable of dominating the battlefield. It was the product of brilliant engineering applied to the science of killing, a technical masterpiece in service of a dark cause. More than 80 years after its introduction, the MG-42 remains a subject of fascination for military historians, firearms enthusiasts, and students of military technology. It stands as a reminder of how technological excellence can make a profound difference in combat, how weapons can carry psychological power beyond their physical effects, and how a single well-designed tool can influence its field for generations. The MG-42 was the buzzsaw that tore through Allied ranks on the Western Front and elsewhere. It was feared for good reason. And its legacy, both as a weapon and as an influence on firearms design, endures into the present day, a testament to the skill of its designers and the grim effectiveness it demonstrated on the battlefields of World War II.